Hello, everyone. I'm your podcast host, Brent Van Conant, bringing you another in our series of recordings focused on practical advances in soil health for Western Canadian farmers. These recordings are part of a larger soil health initiative coordinated by Assiniboine College, bringing together a network of many Western Canadian grower groups and other organizations to continue to advance soil health in ways that accommodate the unique circumstances of each farm. This podcast and the overall soil initiative are made possible through the generous support of the Weston Family Foundation. If you like what you are seeing and hearing, tell a friend and feel free to check out our website, soilhealthnetwork.ca, to find out more about our soil health project. Thanks for joining us. I'm really pleased to have Mary Jane Orr with us today. Mary Jane is the general manager for Manitoba Beef and Forage Initiatives, Inc., where she leads a dedicated team to advance Manitoba beef and forage industry through engaging stakeholders, evaluating on-farm information, and extension for sustainability of farmers, the public, and the environment. She deeply values the opportunity to collaborate with producers, researchers, education providers, extension specialists, conservation groups, and all stakeholders in field testing management practices and growing understanding of improved production in Manitoba. She comes to us with a PhD from Purdue in soil microbial ecology in agricultural systems. What a mouthful. She's a professional agrologist and certified crop advisor, and her experience in ecology and agronomy gives her a unique perspective on facing challenges in agriculture today. So good to have you with us, Mary Jane.
Goodness. Thank you, Brent. Thank you for the opportunity to have a conversation with you.
Well, and not only did I fumble through the bio that was provided, um, I talked to a couple of your colleagues over the last little while, and um, e- each of them told me a little bit about their experience in working with you. And
Oh,
I
dear.
heard dedicated and passionate about agriculture, smart, knowledgeable, and a great partner to work with, persistent,
Oh, dear.
professional, well studied, and can see where things need to go. And I really liked this one. Possesses in one package all the intellect, disposition, common sense, ethic, and passion necessary to deliver an impactful pairing of research and extension, probably in any discipline.
Oh, my goodness.
And you and I haven't known each other that long, but I think those descriptions are quite correct. Nice to have you.
That was a bit daunting when other people provide comment, but that is very kind to hear. Thank you for taking that approach, Brent.
It's not meant to be pressure. It's a part of our curiosity about and speaking of curiosity, the world that you have chosen, including your undergraduate work and your PhD work, was a pretty deep dive into soil and complex systems. Where does that original curiosity come from?
It's gonna sound really cheesy, but I grew up on a mixed farm south of Carberry, just outside of Spruce Woods Provincial Park. And I spent my summers checking cows and pastures. And so I spent a lot of time uh, walking, just outside in nature, not really realizing it, and just kind of probably bored, and kicking over rocks and looking and seeing what's there. And that ability to be observant and take joy in observing things
Hmm.
while out in nature, I think really set me on my path to pursue what originally was a degree in botany. I don't think they offer that degree anymore at Brennan University. So yeah, just straight up the study of plants, real plant
Okay.
nerd over here. But through that coursework, I had some opportunities to work with a mycologist in that department
Okay.
and do some summer research projects and started kind of going from what I could see to what I couldn't see
Hmm.
and doing that lab work to kind of visualize what was happening. What are these different organisms doing things in the soil? And then that just really set me down a different path. Because when I started my undergrad, I honestly thought I was going to be a high school teacher. Like my teachables were going to be botany, or biology, I guess, and geography. So I was like, yeah, you know what? I enjoy working with people. I'm reasonably patient sometimes, and I thought teacher, that'll work. Um,
Well, to
but
be fair, I've looked at your bio and you've done lots of teaching and lots of mentoring and
yeah,
that
no,
hasn't been lost in your career, but you certainly took a deep dive into some
mhm,
complex systems in your PhD. If I got this right, an evaluation of multiple different cropping systems and what that meant to carbon and health and a
mhm.
number of parameters of soil. What what came of um, that sort of bubbled up your enthusiasm of sort of staying in that field and brought you to what you're doing now?
Well, in my initial PhD work, it was very much the pursuit of I wonder what's happening. So, what
Hmm.
information, like to try and understand what's happening in the soil. So, kind of the question was, if we're trying to grow lots of plant biomass, what are unintended consequences of doing that in a system, for nutrient cycling and carbon
Uh,
sequestration? So that was back in the early 2000s or mid 2000s, like 2007 to 2012. And we really, I mean, the history of soil microbiology as a discipline goes back, you know, to the 1800s, right? Like it's a very
yeah.
long history of people trying to figure out what's happening in the soil. So I worked in a lab with a traditional soil microbiologist that also used a lot of like all the toolkits in the box. So we use traditional soil microbiology, which would be like enzyme assays. So, is nitrogen being mineralized out of the soil based on how that land is being managed.
Okay.
So yeah, I used a whole suite of different techniques. So I was really, I don't know, I like shiny things. So I was just all about learning methodology. So I really was like, okay, well, how can I get at this question? What are all the different tools I can learn? And that was most of my PhD. When I started doing my postdoc work, um, in a different kind of with a different lab group at Purdue, it shifted more into system output. So I was really blessed to work with a really multidisciplinary group. So we had like a plant physiologist, a plant nutritionist, watershed
What do you
modelers,
mean by system outputs? Like,
net carbon emit, like net greenhouse
okay,
gas emissions, net productivity, uh, what your nutrient levels are in your soil. So are you depleting or building up or
okay,
maintaining your soil fertility? And so having those different groups and all work, we're kind of bringing 3 or 4 lab groups together. We got to all learn about each other's work, but then also work
okay.
collaboratively to push everything forward. So it was a really great opportunity to then I started doing like static chamber greenhouse gas emissions on 2 different sites. And yeah, monitoring, if we're at the time it was some perennial systems and corn, soybean, different production systems, and the dual purpose sorghum. And so how, we're kind of following best management practices to grow these things. Uh, what is happening in gases coming off the top of the soil? What's happening to nutrient dynamics in the soil? So is it more of a denitrifying emphasis? Are you seeing any free nitrogen fixation in that environment? So are you gaining any nitrogen? Are
Yeah.
you seeing more organisms that, reduce nitrate away and increase conditions for leaching? Do you have more carbon sequestration happening? Are you seeing more organic matter? Are you seeing more
Hmm.
microbial biomass or less? And then what is actually the productivity of the system? So are we
Okay.
seeing, higher yields or more biomass being produced? So it was a pretty, like a lot of different pots on the fire, but it was just very engaging, consuming work. Yeah.
With a pretty cool interdisciplinary team.
And then to see the impact of it. So
Yeah.
from my undergraduate work, I just loved the science of learning it. So getting to culture fungi out of the soil, to get to learn about, how to identify things with a microscope. I just really, really loved that work and the fascination of how these different organisms exist in the environment based on ecology. So, do they have a food source? Is the moisture conditions right? Are the temperature conditions right? So, understanding what causes something to be somewhere, and then can you find it and understand those different aspects of, if you create it, they will come kind of thing.
Yeah.
Right. And so I just really enjoyed that. But it was kind of a comment I had was that there's not a lot of jobs in just pure ecology. So
Hmm.
you need to be applied. So you need to be doing something that has some deliverable for the greater greater population of the world. And so initially I kind of thought maybe bioremediation, but then actually I landed with more grant funding and more broader support in that agricultural
Okay.
context. Yeah.
Well, and here you are in taking that um, academic curiosity and bright shiny things and through the microscope and all to
Yeah.
now in a role that's pretty much in the field, boots on the ground,
Yeah.
messing with the Manitoba Beef and Forage initiative.
Mhm.
Um, where are the things that you saw in the sort of the academic understanding that are presenting themselves now in this just sort of real practical farmer logic kind of world? You and I have talked about this whole soil network initiative that we're, we're um, we're trying to do this in a practical. What does that mean for farm choices that are reasonable and repeatable
Mhm.
and make sense at a farm level? Um, where are those linkages that are warming your heart, going, hey, that this is actually working and I can see it happening?
Yeah, no, it's interesting how things kind of come around. So I'll answer that in kind of two parts. So, like, to go from being in the field and being in the lab to wanting to work more directly with production, like primary production and with producers, really came out of a side project with when I was postdocing to work with Dr. Eileen Klidivko, who was leading an initiative. It was around 2012, and it was really, really fascinating. In the state of Indiana, they had a multi-organizational group come together. So they had NRCS, USDA, Indiana Department of Agriculture, and then the Land Grant University of Purdue. And then they said, okay, we're going to work with, and that was right around when cover cropping was becoming kind of a big deal down there.
Okay.
And so they worked with 12 different farmers. And and again, it was also kind of that transition from talking about soil quality to soil health. So that little bit of a
Hmm.
shift of kind of rebranding soil biology. And so they worked with 12 different farmers and went out to each farm. They set up test strips. So this is all sounding really familiar, right, Brent? So we set
Yes.
up a bunch of different test strips of, what worked for their equipment, for what they were interested in doing. And then they went out and took kind of like a barn building of soil sampling and collected, soil samples across all the farms and all their sites, and then sent those to 4 different labs for kind of the suite of, this is a soil health assessment
Okay.
for your property. And then they got all this data, and then they didn't have a single soil micro person on the team, and they're like, oh, what do we do with this? And so I got ringed in, and it was actually incredibly humbling because it was all data that I had worked with. It was all data that I had collected in my own lab experience, right? And then, okay, so summarize this in a way, synthesize it, and then you're going to present that to these 12 farmers.
Hmm.
And that I'd never done before, right? Like, yes, like was raised in a farming background, but all of my education and professional experience had been academic. And so, yeah, to be in a hall somewhere, no name Indiana, with, all these producers And they were asking exactly the same thing people are asking today. What does this mean for my farm?
Yeah.
How do I use this information to make a decision?
Right.
And I didn't have an answer for them because like I used, different multivariate statistics to basically determine of all the
You,
different
you
parameters. This is the one that was most influential in making your farm or
you're
this field
carrying a
or
lot of
this
pressure
state.
here, thinking that you were supposed to have a clear answer for them. It's vexing
Right?
scientists for a
Yeah.
century.
But
Take
it
a
was
little
a
pressure off
challenge.
yourself.
It was a challenge. And I
Good.
think it was a really good one because I was more focused on information for the sake of the information. So, like to
Mm,
build an understanding of a system as opposed to seeking information for a recommendation. Those are two
yeah.
very different things,
Okay.
right? And so there's
So,
a really rich body of research about how do we better understand a system and identify where there
okay.
might be some cause for concern. Like if we do this, we see elevated leaching coming out of different systems, right?
Right.
Whereas to be able to apply ecology, which is what soil health is. It's multiple
Right.
different factors interacting in an ever changing environment,
Yeah.
like whether it's temperature or moisture conditions. And so it's really challenging to translate an ecology understanding to I have this measurement. What does that mean for my yield
Hmm.
goal?
Yeah.
And so I've thought a lot about this, and I don't know. So I'm really excited and encouraged to be able to continue doing like demonstration work at MBFI through to try and again build an understanding of when we have these conditions, we see these things increase. And
Okay.
so we do have a couple projects that are evaluating soil health under different management systems as part of kind of an applied demonstration. But to get to that, what does a soil health assessment, how does that translate to more bushels of canola per acre? I think it's going to be really challenging because if we think backwards to how did we get to those fertility recommendations from conventional soil tests, that was based off of reliable measurements. So if we're looking at the most understandable thing would be nitrate, nitrogen.
Right.
So if I have a bucket of soil and I repeatedly measure nitrate, nitrogen off of that bucket of soil, am I going to get a fairly close to like that spread of the highest number to the lowest number isn't going to be too crazy. But you recognize there is variability within that bucket of soil.
Hmm.
But reasonably, you're going to have some reliability in the reproducibility of that test. And then if I know from years and years, I don't know how many site years it would be, but all the small plot work where they did ramps of this plot had zero nitrogen applied, this one had,
Yeah.
in 10-pound increments of increased fertility on how many plots across how many land grant universities across all of the
Right.
United States, across all of Canada, reproduced every single year for every single variety, let alone every single crop, they develop a data set that creates a curve.
Right.
And the reliability of that curve under these moisture conditions, like in a wet year on this soil type, because they've collected the data and plotted it against this reliable measurement against this is what a reasonable expectation based on 70 years of data is for a yield goal. And
So
so to be able to get that graph for, I don't know, the fungal to bacterial ratio from a phospholipid assay or
we may all be
a,
retired before anybody makes any real.
well, we have
Uh,
to fund it first, right? So
okay.
that's a significant body of work that has to be carried out over a lot of different soil types, for a lot of different crops, for a number of years, because we know we can never get one year the same as another.
Right.
And
Right.
so just to generate those site years and to be able to plot that is going to be challenging. I think we're getting closer.
And would it ever be as predictable as something like a like a nitrogen response curve?
No,
The
because
dynamics are so inter.
ecology, it depends, right?
Yeah.
So those a lot of those really dynamic, really responsive measurements are going to where you're measuring microbial biomass or how much carbon dioxide, whatever's alive in the soil is breathing out. Those are incredibly sensitive to temperature and
Yeah.
incredibly sensitive to moisture and
So,
pH.
so Mary Jane, with those
Mhm.
complexities in mind,
Yep.
um, what is it that you and your colleagues are leaning into to say, well, we that's bigger than we can slice all on our own.
Mm.
What's the slice that you're going after that I think is the kind of meaningful measures that encourage you to say, the results of this work are really going to help producers make some decisions in these areas. That's what we can do, and that seems like it matters. What gets you up in the morning in the projects, the specific projects that you're working on right now?
I hate to oversimplify it, but I would say that just good old fashioned organic matter
Hmm.
and water management on a landscape seem to be very straightforward and have a more one-to-one relationship to seeing positive outcomes in kind of building the resilience or kind of
Okay.
that natural capital of your land base. And so we can recognize if we're able to increase our organic matter of our soils, that's going to have a lot of really positive things. So it may not, I mean, and that organic matter or soil carbon we might with people generating more data, we might it might be more achievable to get that if I have this level of for a certain soil type organic matter or soil carbon, whether whichever measurement it is, um, that means I'm going to be in maybe this window of productivity for that
Okay.
same soil type. So there was some really interesting work analysis done in Alberta where Stuart Chutter worked for basically it would be the crop insurance, um, same type of position, kind of whatever the Alberta crop insurance
Hmm.
technical name is. And he looked at some soil mapping work done by a living lab group, Kim Cornish's group. They did soil mapping and then they used that data set to evaluate insurance claims, so yield reporting,
Okay.
and had some really interesting results on that. Again, in the same kind of soil type, uh, one that had higher organic matter was, I can't remember the exact details off the top of my head, but would be, X percentage more likely to have a higher yield, or
Okay.
the ones that had low organic matter were in, X value more likely to be in a claim position in a given year. So that is really interesting work because then you have the nuts and bolts of crop insurance data
Mm.
against soil data. And you can see that if you're investing in building organic matter, soil carbon, which has all these other trickle down positive ecological benefits from soil health and soil biology. But we just simplify it to those parameters, we can see a direct relationship with yield potential or risk to be in in crop insurance claim
Okay.
position. So that I think is incredibly interesting
Yeah.
and possible to get at that with some big data.
And I
And
don't think you're going to find anybody argue to say that on most soil where we've depleted organic matter, it would be to our advantage to increase the organic matter back to what
absolutely,
it was
yeah.
natural state was. But how we do that,
Mm,
convenient if you're near a feedlot that's a mile away, and economically you could put on a whole bunch of manure and obviously in your beef and forage
mhm.
initiative, you've got that interaction. Where are the reasonable ways? We've we've reduced tillage so that we're not depleting organic matter at the
Mhm.
rate that we once were. But actually building organic matter, aside from applying manure, are there are you seeing anything that gives the opportunity for relatively rapid improvement in organic matter? Or what does that look like that we should be paying attention to over and above a zero till world, you know?
Yeah, I think if you go to those principles of whether you're talking about soil health or regenerative agriculture, it has to come from somewhere. So carbon is a product from photosynthesis. I mean, there is no creation. I mean, the laws of thermodynamics mean you cannot create something from nothing. So you have to have something there to do the thing to make the thing. And
Yeah.
so that means having something growing. And so we have an advantage in livestock industry in that we have perennial grasslands, but we also have a lot of annual cropland production, and we also have a lot of producers that are very diverse in their enterprises and will utilize annual cropping fields to either grow forage, annual forage um, for their operation, or they may also be grain farmers and livestock producers at the same time. And
Hmm.
so being creative in finding systems that work with your operation and your overall
Hmm.
rotation and your overall um, kind of logistics, right? And so what's going to work is going to be very unique to the context of every
Okay.
single farm. But anytime that you can increase the growing window of plants in your fields is going to be a beneficial outcome. Anytime you can increase the diversity, that is going to see a benefit. And so whether that's within your rotation, so maybe you're growing monocultures, but you're diversifying the year in, year out, what
Okay.
those things are. Maybe you're integrating a 3 to 5 year alfalfa rotation, or like maybe you're resting your land and finding a way to, maybe you're pulling out a small piece and having that go into, an alfalfa stand and then let that kind of build up. And that might be also a tool for handling, herbicide resistant weeds. Like there, it could be a part of your whole system. So
Okay.
when we think about how do we move forward in a modern agriculture, using all the tools we have, but remembering the old tools as well. So a lot of that knowledge that would have been from a mixed farm operation from, the 20s and 30s of how you would
Mhm.
utilize diversity and utilize, different things to be able to make it go on a smaller footprint. I don't think we'll go back to that, but there may be some knowledge from there that you could tweak a bit
Yeah.
and integrate it into modern farming systems. So
So
whether
in
it's
this in
cattle,
this in the circles you're traveling in, I'm I have a farm, but I'm no cowboy. I am not going to be managing livestock. But where are some of the interesting kind of relationships maybe between a livestock grower and a and a monocrop program where um, if we thought about it a little bit differently, there's some crossing over that where are some of the bright spots in either what you're experimenting with or you've seen others experiment with that sort of opens up some possibilities?
yeah, it's a challenge. Livestock are not for the faint of heart. Um, the kind of spots where I think it's going to work is when it makes sense economically. And
Hmm.
so if you have an annual crop, like a grain growing operation, and they're interested in, doing a full season cover crop or something, or they're interested in maybe taking a degraded field that's been showing, lower yields, and it may make sense to pull it out and have it go into an alfalfa grass stand for 3 years uh, as part of their overall rotation. Where livestock comes in is that then that creates an income revenue stream to support potentially a costly investment into
Okay.
building that resilience or building that soil health of that field.
Yeah.
And so that could look like either you have a custom grazing setup or you make relationships with producers that are willing to move cattle around and bring them in and bring them out
Okay.
on when it makes sense and make sure that the field conditions are right for having livestock on them. or maybe it's having custom people come in and put up that feed. So maybe you're growing a diverse mix. And instead of having cattle grazing it, maybe that's harvested off as a winter feed source. And so you
Yeah.
have maybe have someone come off, and then that's something that you can market um, as a high value feed product. And so there's a lot of different ways. And so that kind of would provide an income stream above and beyond. You recognize the value of increasing diversity. You want to have the positive outcomes of having that growing, but you also have to, you're paying land, you're paying taxes and possibly rent and on every piece of land. So you need every piece of land to have an income stream, right?
Right.
And depending on what you're willing to do as an investment, maybe you're willing to take a loss economically on a field because you recognize the investment in building the resilience of that field, like kind of an investment in that natural capital versus, what, that just doesn't pencil out. We need to have another way to make this work economically
Okay.
as kind of income streams coming off of a parcel of land.
Yeah. Well, and I really appreciate the economic sensitivity of
Mhm.
this is an enterprise that has to make some sense, generate income, pay some bills,
Absolutely.
and what's my next available choice? And they aren't all good ones sometimes. Um, where do you think the greatest potential exists for uh, migrating from? I go back to the very beginning where you talked about your project that said there were some unintended consequences, and I think many of us are realizing that our conventional systems, although being have been pretty economically viable for a lot of farms, we we may have underestimated some of those unintended consequences, and uh, you can only get away with some of that for so long. Um,
Mhm.
how do you how do you lower the risk of those unintended consequences, make a transition to something that that uh, that has a little more resilience as an ecosystem and as a economic system?
Mhm.
Um, One of your colleagues said you see things out into the future. Now I'll lean on that to say where where do you think we migrate to in the
Mhm.
in the in the practices that are going to change next reasonably with all of those weird pressures?
Yeah, I think it's an incredible challenge that we're facing as an industry. What is the next revolution? When you look at the advances made from the 70s to now, from the 40s to the 70s to the 2000s, like when you look at how much things have changed, but then not changed at the same
Mhm.
time, and you have pockets of extreme advanced production and then pockets of things have been done the same for three generations, right? And
Hmm.
so it's really fascinating and complex landscape of production. And so I think to move it forward, we have to keep the majority of the tools in the toolbox. And I think we have to have open minds to what, and being able to sift through bombastic claims and what is it, miracle cures in a bottle, like, so
Yeah.
there's all the different things that may have actually worked really well in a given circumstance and setting, but there's always a grain of salt of context. And so for producers and everyone, all of us that are talking to producers, is to kind of keep humble and that know that we may not have all the answers, and to keep our ears open and look for what is going to work for people that makes sense for them for their lifestyle. Like, we can't do everything. So it has to be something that we're capable of incrementally increasing or doing. And it has to make sense in a way that we can make a living doing it. And so it's a really, really hard space to try and push things forward. I think your initiative with the Soil Health Network of building peer groups for people to share their experiences, because there's also an incredibly human aspect to it.
Hmm.
And to, as I kind of mentioned before, to not forget some of the things that we used to know, in terms of how do we deal with weeds? How do we deal, like when we look at all of the different things that may limit our productivity for a given piece of land, am I, when we talk about precision agriculture, we often think about, precision fertilizer or seed placement. But am I being precise in the use of this land? Is this the best use of this land for what I'm trying to do for it?
Okay.
Or could I possibly, carve out pieces that may be able to be accessible? This is my conservation hat coming on, but
Okay.
maybe you can be a bit more strategic in pulling out some pieces of land that may be better suited for taking out of production. And so maybe your total acres might come down, but you turn that into a refuge. You have you're building ecosystem benefits into your landscape so you can focus your most investment in your highest productivity land base.
Okay.
So that, like, I think that's just one idea. I mean, there's a lot of different ways we can try and incrementally build that in. I know there's also the argument against incremental improvement. I
Hmm.
think there could be an argument that, we got to burn it down and rebuild it and make it right, but that's just harder for the majority of people. I think if we look at all these different principles of like, okay, the less I disturb the soil, the better, because every time I disturb it, I'm burning off, I'm adding oxygen to the microbes, and they're going to utilize whatever's around them and it's going to burn off carbon and limit that organic matter production. Okay, we know if something's growing, it's contributing groceries to the soil. So if I can get more things growing, that's a good thing. I know that different things have different roles and have different contributions. So if I have more kinds of different things,
Hmm.
that's a good thing. And so if we try to find pieces of all these different kind of principles of building soil health or
Yeah.
regenerating the land, you can find pieces that work for your farm, get good at doing that, and then you start challenging yourself. Okay, well, what's the next step of improvement out there for me?
Yeah.
And there are some real, like, so there's, sometimes thinking about resilience or building your soil can be a bit abstract, but in a really practical term, when I mentioned before water, like water management, if the trafficability, so if you're increasing the organic matter of your soil, you're going to see a better water relationship
Right.
with your rainfall and runoff. So you're going to have what they talk about as effective rainfall. So when a raindrop falls out of the sky and lands on a little inch of soil, is it going to soak in and stay there for me to get through a dry spell, or is it going to just whip right off the field and take nutrients with it that I paid money for and then cause problems downstream?
Right.
And so and then it's like, okay, well, I had a big rainfall. Do I have to wait a week to get onto my field because there's ponding? Like it's not
Yeah.
soaking in. And so just trafficability and the water status of your soil column, like that soil
Hmm.
profile, can make or break an operation in a dry year and even in a wet year. Because if you don't have the soil structure to hold your equipment up, you're not going to be able to get into that field. And so
Right.
that's one of, to me, the most relatable, whether you're measuring it or not, positive outcomes of trying to make an investment of improving the health of your soil.
Yeah. You um, the thought comes to my mind that um, all those things depending on a lot of things.
Yeah, I
So,
know it's terrible. And one
when
answer is very
but I think an important feature of that is and maybe even some systems might completely collapse and we do have to burn them down. And in some cases it'll be incremental, and in some cases it'll be both at the same time. even thinking about within a single field, there's places where we need to change the strategy on that certain section.
Mhm.
So it shouldn't be a stretch to believe that we probably need to change the strategy by township, by by soil
Absolutely.
type, by province, by um, uh, uh, all growing conditions, by all kinds of things. And
Mhm.
your idea of keeping as many tools available, some old ones, some new ones, some we haven't even thought of yet.
Absolutely.
Uh, it'll be a
Mhm.
dance of all those things. And when we get that right, much of our focus here is about how do we get that right for the grower who
Mhm.
has a living to make, who has decisions to make, who has a intergenerational asset in land that they want to preserve. Um, when we get that right, um, what are the secondary and tertiary and other steps that people beyond agriculture will benefit from? I hate to lead with them because we've had so much difficulty with the people who want things from farms, ask
Yeah.
for unreasonable things for farms. But if we do reasonable things at farms, what benefits can we provide beyond just good production? And how do we own the pen to write that narrative?
Yeah. I just had an interesting conversation with my dad, ranting and raving about, everything wrong in the world. And, we provide everything. It's the air that we breathe, we are stewards of the environment. And from that, we are also the creators of everything we eat, most of what we wear, most of
Hmm.
what we need to live on this world. And so there is this huge challenge of being disconnected from primary production. But even within primary production, we are stewards of the land. And that puts us in that tricky position of, finger pointing of, you know, you shouldn't be doing this or you shouldn't be doing that because of XYZ, negative environmental outcomes. So whether it's greenhouse gas emissions or water quality, we can over the years, over the decades, agriculture's taken some bumps and lumps for its production systems, but we're missing, and as you say, like as we're getting it more and more right along the way, how do we flip that narrative and really effectively tell the story of the good stewardship that is happening across Canada,
Hmm.
that is seeing positive outcomes of improved productivity in our soils, improved relate or what would be called improved water management, so that we see lower losses of nutrients from our fields margins, and that we see an increase in those natural areas that are really refuge and habitat creation. And so what I really enjoy about my work at MBFI is this kind of crossover nexus between conservation and production when we talk about sustainability. And to be fair, like beef cattle production is in a real sweet spot in that we need perennial landscapes. It's the cheapest way to raise cattle in the summer. And
Hmm.
there's an inherent, massive ecological benefits to maintaining grasslands, and whether they're tame pastures or native prairies, there's this huge benefit to the world by us doing that. And so we're working on trying to tell that story better. But even within cropping systems, if managing the margin of your fields, is it looking at how can we really capture those ecological benefits of small management changes? It's not a huge footprint, but there are going to be opportunities either through more effective nutrient management, as I mentioned, introduction of marginal areas that are
Hmm.
retained as more natural infrastructure, um, looking at streaming, how can we, if we're applying nutrients, how can they be with the most precision and impact be put into the product that we're growing, as opposed to paying or losing excess nutrients out of our production system, as well as looking at um, really our overall footprint on the landscape. So I think there's a really positive story to tell, especially from a stewardship perspective, for basically maintaining the environment that we all live in.
Well, I'm glad we didn't go down the rabbit hole of all the things that are wrong in the world that you and your dad went into. Because,
Yeah, it's a long, long Sunday afternoon
uh,
conversation.
but
Yeah.
I do appreciate the the optimism and the continued pursuit of answers that folks like you bring to these challenging questions. I'm pleased that there's people as bright as you and with as big a heart as you that are working on problems as complicated as this. I've really appreciated the time we've had today, and good luck on all the important work that you continue to do on all of our behalfs.
Thank you very
Thanks for
much, Ben.
thanks for your time today.
Thanks.